Hello, and welcome to the next video in our geometry course. Today we're going to continue talking about triangles. We're going to talk about congruency specifically. First, I want to do a little bit of review. So as a reminder, in order to find the symbol for reviewing, we have this little triangle. To simplify that, we are talking about a triangle, and A, B, C is the vertices of that triangle. Remember that congruent means that if two structures in geometry are congruent, then they have the same measure. For example, if I have the measure of angle ABC is the same value or same number as the measure of angle DEF, then we can say that the angles themselves are congruent. And finally, in class last time we talked about the triangle sum theorem, where if you have a triangle and you add the three angles together, it has to equal 180 degrees. In other words, if triangle ABC has angles A, B, and C, then the measure of angle A plus the measure of angle B plus the measure of angle C must be 180. It doesn't matter what type of triangle you have, whether it's an obtuse right triangle or you can't have an obtuse right triangle, sorry, an obtuse scalene triangle or a right isosceles triangle, the angle measurements added together will equal 180 degrees. Now let's consider these two triangles. The definition: two triangles are congruent if their corresponding parts are congruent. Remember, the definition of congruency simply means that if the two structures have the same measurement, then those structures are congruent. Well, a triangle has three angles and three sides. In order for a triangle to be congruent to another triangle, all of those parts must be congruent to the corresponding parts. So, in other words, if the corresponding parts of a triangle are congruent, the angles are congruent. What do we mean by corresponding parts? Angles or vertices must be corresponding, and sides must be corresponding. You'll see in the diagram that we have three lines here and three lines here. In geometry, that means that these two pieces or segments or a side in this case, would be congruent. In other words, those two measure the same amount. In other words, if we know that the line segment AC is equal to 12, then that would also mean that line segment DF would be equal to 12. So this diagram shows off what's congruent. A, this arc, is congruent to D. Angle B with three arcs is congruent to angle E with three arcs. Angle C is congruent to angle F with the two arcs, and then the three lines and the two lines and the one line. All of those are congruent. And again, all that means is that they have the same measurement between each other. That does not mean that all angles are the same measurement. It means that between the two corresponding parts, those are the same measure. Now, I want you to note that the order of writing the corresponding parts can change in the same way that the same line segment can be named. So as you recall from the very first video, we were able to say a line segment AC or line segment CA. That means the same thing. It's the same structure. Same thing here. If I were to say triangle ABC is congruent to DEF, as it is in here, then we could also switch the order of the vertices. Please note that the corresponding vertices must match up. Since angle A is congruent to angle D, if we start with A in the naming, we start with D in the naming. But if A was the last letter in triangle ABC, then D would have to be the last letter in DEF. That way those two parts match up. So we could name the same relationship in these different ways. We could also have switched this around with this and have it on the opposite side of the congruent sign. But all these statements say the same thing. This triangle is congruent to this triangle. The key thing is that the vertices of the triangles must match. A relates to D, C relates to F, and B relates to E. That's why in these orders you can see C is with F, and C is with F, and C is with F, C is with F, and so on and so forth. So what I want you to do now is I want you to practice writing the congruent triangles. Remember that the corresponding parts have to match up when you're naming the triangle congruency statements. Okay, hopefully you pause the video so you could practice that. Here are 6 different ways. Now, of course, we could flip it around and say that this side is actually on this side and vice versa, but these would be essentially half of the ways you could label these congruent triangles. Note that they're all correct, even though the order is different, they all describe the same relationship, that this triangle is congruent to this triangle. Now that we know what it means to be congruent and what two triangles congruent mean, let's go ahead and talk about how to prove that. As a reminder, congruency means same measure. What this means is that if we were able to show that corresponding parts between two triangles are the same measure, that means that the triangles must be congruent. So if triangle HGL is congruent to triangle POK, then the following is true. Line segment HG is congruent to line segment PO, but that also means that the measure of HG is equal to the measure of PO, and so on and so forth. HL line segment is congruent to PK line segment, and therefore the measure of line segment HL is equal to the measure of line segment PK, and so on and so forth. Notice that there is a lot of different ways we can write the same thing. Just like naming line segments in general, we could flip the order of every single letter in the individual line segments and we still get the same relationship. This is also true for the angles. If we have triangle HGL is congruent to triangle POK, then the following is true. Angle H is congruent to angle P because the measure of angle H is equal to the measure of angle P. That also means the flip side. Angle P is congruent to angle H, and the measure of angle P is the same as the measure of angle H. Every corresponding part are congruent to each other in a congruent triangle, and therefore those measurements for those parts are also the same. Again, note that HGL, so H and P are in the same position, G and O are in the same position, and L and K are in the same position. Those are the corresponding parts, and therefore they are congruent and the same measure. So now we want to prove triangles are congruent. In order to show that two triangles are congruent, at least 3 of the corresponding parts must be proven congruent. We're going to see that there are 4 situations where if we have 3 pieces of information, we can then conclude that 2 triangles are congruent. In other words, having 3 pieces congruent forces the other 3 to also be congruent. We have 4 basic theorems that we're going to talk about, and we'll use those to prove triangles congruent. Each one focuses on 3 parts. There are acronyms to help you remember which theorem is which talks about what parts of the triangle you need to have congruent. Think of the theorems as if-then statements. If this happens, then they are congruent by this theorem. This diagram shows you the 4 different ones we're going to look at, and you've probably heard them before. SSS, SAS, ASA, and AAS. In the next 4 slides, we're going to talk about each one individually and focus on the pieces of information we need to know in order to prove congruent triangles. Side, side, side. Probably the easiest one is going to show that the 3 corresponding sides of 2 triangles are congruent, as long as they're and show that they're congruent themselves. So if the 3 corresponding sides of 2 triangles are congruent, then the triangles themselves are congruent. In other words, if the sides are congruent, it forces the angles to also be congruent. If this side is congruent to this side, and this side is congruent to this side, and this side is congruent to that side, it forces the triangles all together to be congruent. So let's look at a quick example. Let's suppose we have triangle ABC. In ABC, let's say the measure of side AB is 8, the side of BC is 10, and the side of CA is 6. And then we have, so let's go ahead and label this first triangle. Let's suppose this is A, this is B, and this is C. So according to the information we have, this is 8, this is 10, and this is 6. According to here, we also have KJ is 10. Let's see. So KJ is 10, LJL is 6, and LK is 8. We want to make sure that the corresponding sides match up. So since this is side 8, I'm going to call this one L, and this one K. The question is, because now we have 8 here, because LK is 8, AB is 8. So we could say that A relates to L and B relates to K. That forces this one to be J. If that's the case, we should have this being 10 and this being 6, which notice that KJ is 10, and LJL, which remember this is L, is 6. Notice that the double dot, or the double lines, that is double lines, that's double lines, that's 8, that's 8. Awesome. So what we have is that AB is, the measure of AB is the same as the measure of JK, the measure of BC is the same as KL, and the measure of CA is the same as LJ. By definition, that means line segment or side AB is congruent to side LK, BC is congruent, side BC is congruent to side KJ, and CA is congruent to JL. By side, 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 these 2 triangles are congruent. Remember, corresponding parts have to match, so A is to L, B to K, and C to J. Side angle side has the same idea, but we're looking at 3 different parts rather than the 3 sides. Here, if the corresponding sides of 2 triangles and their included side are congruent, then the triangles are congruent. So let's look at another example. Let's suppose that angle ABC, in triangle ABC, let the length of AB be 8, BC be 10, and the measure of CBA is 30. If we look at the diagram, here's my angle measurement. I'm going to say this is 30 degrees. If that's the case, based on the labeling of our problem, this should be B. Remember that an angle goes a point on one ray, the vertex, and then the point on the other ray. So I could have this be C and this be A. AB is 8, so that's this, and BC is 10, which is here. In the other triangle, we have the measure of LJK. That means that J must go here, and this is 30 degrees. We know that if these are congruent, this must be 8, and this must be 10. Well, 10 is KJ, so since this is J, this must be K, and this must be L. Because those corresponding parts have the same measurements, respectively, whether it's a line, segment, or an angle, we find these are congruent. A or C, oh, I got them backwards. Uh-oh. It's supposed to be CBA is congruent to KJL. But I got them backwards. How did I do that? Let's see, did I mess up somewhere? AB is 8, JL is 8, AB, CB is 10. I must have just messed this up here. So, oh wait, whoops, my apologies. I'm ahead of myself. So we do have angle CBA and LJK. Yeah, that's supposed to be backwards. That's supposed to be angle KJL. But I did line it up correctly here. Oh, I did not line it up here. Man, I apologize, folks. This is angle KJL, and this is supposed to be triangle. So A is L, B is J, and then K. Don't worry, we're going to do more of these in class. Okay. Angle side. So in angle side, if the two corresponding angles and an excluded side of two triangles are congruent, then the two triangles are congruent. I made sure this one was working. Okay. Whew. So we have triangle ABC. We have the measure of angle A and the measure of angle C. Since we know the two angle measurements, we'll let that be A and C, and this must be B. A is 15 degrees, C is 38 degrees. We also know that CB, which is this side, that's fine, is 8. Okay? So if I have side L is 38 degrees. Since C is 38, L must be over here, which means this is 15. And then this is, that's J. This is K. We're given LK, which is also 8. Now, even though the lines over here, I can go like this and say those are the same. Since I still have an excluded side, it still counts, as long as it's not the side that is in between the two angles. But that gives me that CB is congruent to LK, and that angle A is congruent to angle J, and angle C is congruent to angle L. Therefore, triangle ABC is congruent to JKL by angle side. The final one we have is angle side angle. If two corresponding angles and their included side of the two triangles are congruent, then the triangles are congruent. In the diagram here, it says we have one angle here, and the side in between them. So the difference between angle side and angle side angle is the position of the side. Do you include it? Is it the side you're talking about in the middle, or is it one of the other two sides? So here's an example. Here we're given the measure of angle A, so I'll call this A, and that's going to be 48 degrees. B is the other angle we have, so that's going to be 37, 37. Now it says AB is 10, so the side in between them is 10. In the other triangle, we have 48 for J, which means it would be down here, because this is 48. And then we have L, which is 37 degrees, and then we have 10 in between them. So since the two angles and the included side, which is the side in between the two angles, is congruent to each other, or is equal to each other, therefore each corresponding part is corresponding to each other. And this should be JL with a line over it. Everything else is fine. I just missed that K. JL. All right. So then A, B, C is J, L, K. By angle side. The last thing I want to talk about in this video is CPCTC. I do know this video is a little long and I do apologize, but it's important to know this. CPCTC stands for corresponding parts of congruent triangles are congruent. Basically, this is the, or we could also write, if two triangles are congruent, then their corresponding parts are congruent. Essentially, this is the converse of what we've been using as a definition of congruent triangles. Remember that two triangles are congruent if their corresponding parts are equal to each other or congruent to each other. Here it's just the converse. We flip it around. So if we have congruent triangles, then that says we have corresponding parts are equivalent. So if we have two triangles, we have D, E, F, and X, Y, Z, for example, and we already know that these two triangles are congruent, then we already know that line segment DE is congruent to line segment XY. We know that line segment DF is congruent to XZ, and we also know that line segment FE, 1, 2, 3, is congruent to line segment XY. We know this because of the way the letters are. D corresponds to X, E corresponds with Y, and F corresponds with Z. That also means that the angle F is going to be congruent to Z. Angle D corresponds with X, and E corresponds, it's really dark, let's try red, and red, E corresponds with Y, which can be summarized here. And if these parts are congruent, they must be the same measurement. So in our definition of congruency, the measurements are the same, that means the structure is the same. Oops. Okay. In class, we're going to go over these again. We are going to practice with them. That is the biggest thing. We're going to be utilizing these to prove two triangles congruent. And if we do have two congruent triangles, can we use CPCTC to show the rest of the triangle is congruent?